Hey, do you think the speed of light is just a number? 299,792,458 meters per second. Super fast. Crazy fast. The fastest thing we know. Okay. But why is it the top speed? Why? Can't anything go quicker? What's stopping it? Most kids never really wonder about this. They just say, okay. Einstein said it's the cosmic speed limit. That's how it is. But that's not really an answer. That's just repeating someone else's words. When you actually ask why nothing can beat light, when you dig down deep, you find something so wild, so totally different from normal life that it flips everything you thought about space and time. The speed of light isn't just a speed. It's not just the fastest thing. It's the actual skeleton of the universe. It's stitched right into space. And time's so tight that going faster than light doesn't even make sense. Let me show you super easy. Let's start with something every kid knows. Stuff falls. Drop a toy, it falls down. About 16 feet in the first second. That's what Galileo found out. Drop a ball, drop a rock, drop anything. In 1 second it drops 16 feet. Now look at the moon. The moon is zooming around the Earth. It's not falling down, it's staying up there in a big circle. But wait, is it actually falling? Think about it. If the moon just stopped moving and hung there in space, what would happen? It would crash straight into Earth. Gravity would yank it down. But the moon is flying sideways super fast, right along the edge of its circle. So while gravity pulls it down, it keeps missing the Earth. It falls and falls but never hits. That's what an orbit is. Falling forever while zooming sideways fast. Now here's where Newton got super smart. The moon is 240,000 miles from the center of the Earth. We're standing on the surface only 4,000 miles from the center. So the moon is 60 times farther away than we are. Newton said, what if gravity gets weaker the farther you go? What if it follows this rule, double the distance, gravity gets 4 times weaker? Triple the distance, 9 times weaker? It's the square of the distance. If that's true, at 60 times farther away, gravity should be 60 times 60 is equal to 3,600 times weaker. On Earth, stuff falls 16 feet in 1 second. At the moon's distance, it should only fall 16 feet divided by 3,600. That's about 1/12 of an inch per second squared. Let me say it clearer. In 1 second, the moon should fall toward Earth only 1/12 of an inch times 3,600, because of the time squared thing in the formula. 1/12 inch times 3,600 is equal to 16 feet. Exactly what we see on Earth. Newton figured out exactly how far the moon should fall in 1 second if gravity weakens with the square of distance, and it matched perfectly. The moon is falling exactly the way Newton's rule says it should. This was huge. This wasn't just a guess. This was a real prediction. Newton took one fact, how fast stuff falls on Earth, and connected it to a totally different fact, the moon's distance and how long it takes to go around Earth. 2 things that seemed unrelated suddenly fit together with one rule. Gravity. There was no going back. Then Newton went even further. He calculated what shape planet orbits should have if gravity works that way, and he got ellipses. Guess what? Planets really do move in ellipses. Kepler saw that first, but he didn't know why. Newton explained it. Boom, 3 mysteries solved with one idea. Then tides made sense too. Why 2 high tides every day? Because the moon pulls harder on the water closest to it and less on the water farthest away. So you get two bulges, one on the near side, one on the far side where Earth gets pulled away from the water. 2 tides a day. Just like we see. Everything started making sense. Why is Earth round? Everything gets pulled toward the center. Why isn't it perfectly round? Because it's spinning and the outside gets flung out a little until it balances. Same with the sun and moon. Later, scientists tested Newton's law super carefully with Jupiter's moons. They watched them orbit for years and years. At first it looked like the moons were sometimes 8 minutes early and sometimes 8 minutes late compared to what Newton's math said. 8 minutes. That's a lot. Something was wrong. But then someone noticed they were early when Jupiter was close to Earth and late when Jupiter was far away. Weird, right? This guy named Romer trusted Newton's law so much that he said, "What if light takes time to get here? When Jupiter is close, the light gets here faster. When it's far, the light is late." He fixed the numbers for how long light took to travel, and everything matched perfectly. That was the first time anyone proved light has a speed. We didn't measure light directly. We trusted gravity so much that when something looked wrong, we discovered light itself takes time to travel. That's the cool thing. When a law is really right, you can use it to find brand new stuff. Trusting gravity led us to the speed of light. This started an avalanche of discoveries that's been rolling for 400 years and still going fast today. But once we knew the speed of light, something super weird showed up. Light always goes the same speed. Always. No matter who measures it. No matter how fast you're moving. Let's make it real. You're standing still. You shine a flashlight. Speed of light equals 299,792,458 meters per second. Cool. Now you jump on a super fast train going half the speed of light. You shine the flashlight forward. Normal thinking says the light should go speed of light plus train speed, right? Like throwing a ball from a moving car, it goes faster. But nope. You measure the light, it's still 299,792,458 meters per second. Exactly the same. You speed the train up to 90% light speed. Same thing. 99.9999% light speed. Still the same number. Light speed does not add. It never changes for you. This should blow your mind. Normal speeds add up. Train going 50 miles per hour plus you walking 3 miles per hour equals 53 miles per hour to someone on the ground. But light refuses to play that game. It's always the same speed for whoever is looking. Einstein figured out why, and it's so crazy it still feels weird 100 years later. Time and space are not hard and fixed. They stretch and shrink so the speed of light stays the same for everyone. When you go really fast, your time literally slows down. Your clock ticks slower. Distances in front of you get squished shorter. This is real, not a trick of the eyes. Time really slows, space really shrinks, just enough to keep light speed the same for you. The universe bends time and space on purpose so light always looks the same speed to everybody. That's why nothing with mass can reach light speed. The closer you get, the heavier you effectively become. It takes more and more energy to speed up even a tiny bit. At the very edge, it would take infinite energy. Impossible. Only things with zero mass, like photons, can go light speed. They have to. They don't get a choice. Anything with mass can get super close. 99.999999%. but never touch it. The universe won't let you. Why is the universe built like this? There isn't a deeper. Because the speed of light isn't a rule someone put on the universe. It's how space-time itself is made. Space and time are sewn together into one thing, called space-time, and that fabric has a built-in speed limit for how fast causes can make effects happen. Light just happens to travel at that exact limit because it has no mass. The limit would still be there even if light didn't exist. Another way to picture it, you're always moving through space-time at exactly the speed of light. Always. If you're sitting still, all your motion is through time. You're zooming into the future at 1 second per second. When you start moving through space, you have to borrow some of that motion from time. So, time slows down for you. The faster you go through space, the slower you go through time. If you ever reach light speed through space, you'd have zero motion left for time. Time would stop for you. That's why light doesn't experience any time. From a photon's view, it's created and destroyed in the same instant. The whole universe is frozen. You can't go faster than light because that would mean negative time, which doesn't make sense. You can't undo cause and effect. We've tested this a million times. Particle accelerators push tiny bits of stuff to 99.999999% light speed and they get crazy hard to push more, exactly like the math says. GPS satellites have clocks that run faster than ours because they're moving fast and feel less gravity. Ignore that and your phone would be off by miles in one day. Muons, tiny particles made high in the sky, should die before hitting the ground, but they're going so fast that time slows for them and tons more reach Earth than should. Exactly what Einstein said would happen. It's all measured, not just stories. So why is the speed of light the limit? Because space-time itself has a built-in maximum speed for cause and effect. That speed is c. You can't break it without breaking the whole idea of before and after. And this whole amazing story started with Newton watching the moon, Romer watching Jupiter's moons, Einstein trusting that light speed never changes, and thousands of experiments proving it over and over. Each discovery opened the door to the next. That's the avalanche that's been rolling for 400 years, and we're still riding it full speed. Today, the speed of light isn't just a number. It's the secret key that shows us space and time are way weirder and way more beautiful than we ever dreamed. And the fact that we little humans can figure this out, that's the real magic of science. Truth. Pure, wild, beautiful truth.